So hi everyone, and thank you for joining us today for this webinar. So my name is Sofiane Fessi. I'm the director for solutions architecture at Dataiku. I've been in the company over 3 years now, based myself out of Berlin. So today we are going to see in the next 30 minutes how you can, using Dataiku DSS, collaborate, document, version, and deploy data science projects with Dataiku DSS. So DSS stands for Data Science Studio. Dataiku is a French company that was created about 9 years ago. You can find all of the information on the website already. And so, without further ado, let's get started. Maybe quickly to before we start to the actual demo of the tool, quick word on what the actual software does. So as Dataiku as a company, we are the developer of DSS. That's our let's say only solution that we sell. DSS basically consists in offering every persona in the development of the analytics project or the data science project the tools to actually work in the same place, and thus offering one place to cover every step of the life cycle of the analytics project. So DSS comes on top of your existing architecture, can be deployed in the cloud, on-premise, or in hybrid setups. And one of the big strengths of it, as you'll see, is notably that you can actually combine different data sources very easily as a user and as an admin as well. And that you can then start working on your data, whether you are a coder, a clicker, you will find all the tools that you need and that you're used to, let's say, have into DSS. So everything from data exploration, data transformation, data preparation, feature generation, but also, of course, machine learning, deep learning, model deployment, MLOps, and monitoring, and so on and so on. So maybe quickly before we start to move to the actual demo, a quick word on what actually DSS is made of. So DSS has 3 types of nodes. First one that is called the design node, where let's say 95% of the users will be working, where analysts, data scientists, and the business and so on will be exploring the data, building pipelines, training models, and so on. This is also where all of the, let's say, automation, scheduling, and so on will be defined. And then once the project is ready for deployment, it will be pushed thanks to a one-click deployment to the automation node. Automation node, which is going to be, let's say, sort of like batch processing node. So where all of the things that were defined here in the design node are going to be actually leveraged. And then the second type of node for the deployment, which is going to be the API node for the ability to create REST API services with components in the background coming from your projects here or here. So if you want to expose a machine learning model or simple dataset lookup or things like this via API as well. And the pretty cool thing about all of that is that you will be able to have a multitude of design nodes and automation nodes, as many as you want. So this is just an example that you see here. I think in the lights of deployment and versioning, CI/CD and all of this, what you can see here is various nodes for design and automation and API for various staging environments. So all the way from sandbox to design, pre-production, testing, production, you name it. Basically, this sort of like logic of pushing artifacts from one staging environment to the other in just a one click is going to be how you're going to be able to manage the life cycle of your models in production. So now we can, let's say, move on to the tools. So what you can see, what you're going to see during the demo today is mostly going to be in the design node. So DSS is actually installed on a server, which is going to be centralizing all of the projects, all of the work from the teams, and then can be reused and shared. So in the spirit of collaboration, this is very important, of course. And we'll get to that in a second. But what you can see here is one design node with basically the homepage being displayed here. So what you can see is that there is a multitude of projects and use cases. There is no limitation in terms of what type of use case you might build. We cover all verticals. There is no restrictions in terms of data that you might leverage in the project. So structured, unstructured. So working with texts, working with images, working with videos, working with time series, NLP, all of that is something you can do in DSS. And so if we zoom in a little bit more further down to, let's say, to the project level, we can see a little bit how collaboration, documentation are handled on this layer. So this is the homepage of this project, which is here a churn prediction project, which sort of like summarizes, what's been going on, what is the project made of. Here, a quick documentation about the project and description. Markdown is supported, so you can structure that nicely. You can also use the wiki to document your projects a bit more in depth. So for example, if you open this, you'll see that you can create wiki with Markdown also supported, of course, and the ability to structure articles the way you want. So quite nice also for documentation. Now back to this project homepage. What you can see is that you can have to-do lists. So for yourself, so that's sort of like productivity item there. You can also tag colleagues, and quite powerful here in terms of collaboration as well. You could be a data scientist and you'd like, I don't know, data engineer to review something before it's deployed to production. So sort of like pre-deployment model validation thing. It can also be something like, you're a data scientist and you want to ask someone on the business side whether certain data should be included and if it makes sense from a business perspective, or like is this relevant for the use case that you're actually trying to build. And by combining, as we saw before, the business expertise with the data science expertise and maybe the data engineering expertise all in one place, you have much more efficient projects, much more impactful, much better models in general, and higher performance in the end generates more value for the organization. So this is the idea behind all of that. In terms of still collaboration, obviously you want to be able to see who does what on the project. If a colleague has been helping you with one. So all of this is here displayed in the timeline. The timeline basically runs on top of a internal Git that is internal to DSS. This Git can be synced with external repositories with branching, merging supported, and so on, push and pull. You'll see also that you can basically simply use that to go back to a step if you'd like to revert or change. So all of this is going to be there. And again, in the spirit of collaboration, of efficient collaboration, and let's say good model governance, you have access to all of these tools, as well as understanding, who did what and when on a project, and so on and so on. So now we can move on to the actual heart of a DSS project, which is called the flow. So I've got it displayed here. So you can see that this is sort of like a pipeline. On the left-hand side, you have your input data. And so this is basically being transformed step by step. In this case, what you can see on the top branch is my training branch. So this is my training data for my churn prediction project. So I'm using my historical churn data to train a machine learning model. At the same time, I'm doing, in this case, kind of like a mirrored transformation at the bottom for my new data so that I can score my new customers. So we'll get to that in a second. But basically what you can see is these blue squares are data sets. The data can be basically sitting anywhere in the architecture. DSS will have the ability to connect to the data source, which can be set up by the admin, of course. And then once the connection is established, the users can basically start working with the data. So we have another example here of what that looks like. Here combining some Snowflake data and S3 buckets in AWS. Could also very well be some cloud data with on-premise SQL or Hadoop data sets. So how this is handled is that when you will set up DSS in your architecture, you'll start by creating connections to your databases. So this is the list of current connections that we have. So your list here will be empty, but you can use the list of connectors that are here. So if you want to connect to maybe Redshift or, I don't know, simple PostgreSQL database, you'll be able to fill up the parameters of connections here. Maybe select which groups of users should be actually having access to that to these data sources. And once the connection is established, it will appear here in the list, and you can add more and more as you need to. And once the connection is established, DSS will, let's say, crawl and browse the file system of your data source and will represent all of the available data here in the catalog. So this is how we enable self-service, which in terms enable collaboration, basically having direct access to the data that is controlled, governed, and secure, yet again, self-service. So all of these tables can be retrieved. You can search column names here. You can retrieve by connection and other things. The catalog is going to be useful for that, and it's going to be also useful to centralize and reuse all of the components on your instance. So in this case, you can see we have nearly 40,000 components here. So some data sets, some recipes, notebooks, and so on, basically that are available for the user if he has access to the projects where they're located and who can be reused. So again, massive element here around collaboration, around reuse, quite massive efficiency gains there potentially for I guess even larger teams. And so here you can simply filter. You want to retrieve, I don't know, a SQL a transformation or a split of data, whatever. You can simply use that and then maybe use some tags that were used previously, or maybe filter by project name and so on. So all of that is quite powerful for collaboration, of course, and I encourage you to give it a try after this presentation. So back to our project, our data is represented in these blue squares, and so what you can see is that it's represented so like tabular fashion. You have data quality indicators. You have as well ability to see what the type of data it is, data format, as well as type of information that is in the column, which is automatically detected by DSS. And so here, for example, we're doing a join between our churn data and CRM information and web analytics information. And this is done via a visual join. So this allows for, very quickly do a join here. So whether you're a clicker or a coder, if you're a clicker, well, that's what you're going to have to use to do a join. But if you're a coder, you might also find this useful to save time, to use, maybe to convert it to directly to a SQL or Spark SQL script. So this is going to basically automatically generate the code. Quite handy if you have hundreds of columns to join. To switch from the visual to code. One other big thing is going to be that you can switch, basically change where the compute happens. So I'm not going to spend too much time on this, but very important to understand that every step in DSS in the pipeline can be pushed to different components of your architecture, depending on what you have available, depending on where the data is sitting, and so on. So here we can see our visual join. You can see also that all of a sudden our recipe became a Spark SQL query. You see also that it's a different color. Basically, the yellow recipes are the click recipes. The orange ones are for code. So you'll be able to use Python or PySpark, Scala, Julia, and more. And so, for example, if I would like to use this data set here to start a Python script, I can create this here. And this will allow me to edit this in Jupyter Notebook directly in the interface. So coders will feel at home in DSS. You have Jupyter Notebooks integrated into the UI. You have RStudio. You have also ability to integrate with external IDEs like PyCharm, Visual Studio Code, and more. And basically work the way you used to work with your usual tools. You're going to also be able to change the libraries and to have full flexibility in terms of libraries that you want to use. All of that can be managed here as well. And so now back to our pipeline. We have a Python bit here that was just for demo purpose. We can remove it now. And so in terms of our project, as you remember, we've done this join between our web analytics data and our CRM data. We would like to transform, to train a model here. But as you might see, it's not really ideal to train a model with date of birth as is, or some of these features here might do well with some transformation. Maybe we can even generate some features. And so for this, we're going to use a very powerful visual tool, which is the prepare recipe. So this one basically allows you to combine as many as 92 processors, so different operations, some as simple as find and replace, some more advanced like NLP or working with geographical data or with dates data and things like this. Basically to combine these on the left-hand side in a script. So you can see we've already implemented a few of them. So we parsed the date of birth here. We got the age from that parsed date column. And you can see that on the right-hand side, we already have some additional information that we didn't have before. And so the principle here is that the changes that you implement on the left will be reflected right away on the right-hand side. All of this is in memory, just a preview of your output table, but basically allows you to work in an interactive manner with your data. So if I replace in my country column here, for example, Japan by 1, 2, 3, I can see the change right away. And this is really precious and useful to reduce time you spend on data preparation. So whether in this case, if you're a clicker, of course you're going to have massive use of that. If you're a coder, of course you can code all of these things, and in DSS you will be able to do that as you've seen just before. But you might also again want to use that to save time, knowing that you can also code your own processors and create your own custom processors here in Python. So full flexibility there and the ability to use this environment to code, yet to be able to use it in a more interactive way. And again, save some time, be able to see if a change you made, is damaging your data quality or, basically seeing what you're doing in almost real time. And so once all of this is done and you're happy with what you see on the right-hand side, you will click on run, and then and only then the output will be written as per what you see here in the preview. Right? So all of this can also be pushed to different components of the architecture as well. So also quite useful if you have some compute heavy operation to run. And so now back to our flow, we see, of course, our output as per what we saw in the table. You also saw probably that we extracted geographical information from the IP address of our customers, which is also a processor that is there. And now we have a data set that is ready to use to train a machine learning model. So before we're going to do that, we might want to do some further exploration of the variables and analysis. So we briefly touched on it earlier. Basically, you have the data quality indicators here. You can also understand a little better, basic statistics around each variable. So a little box plot here, minimum, maximum, standard deviation, and all of that. You can just like browse through different variables this way. Another very useful tool in DSS to actually explore your data is the descriptive statistics tab in the dataset. So if you want to create some bivariate analysis, you want to understand things like impact of, country, how many pages were visited, the age of the customer maybe, or and the gender on, the churn of the customers. You can very quickly get that in a couple of clicks. Again, something you might be able to click to code, usually, but again, something that you might be able to save time on. And as a clicker, if you're a bit data savvy, statistics savvy, and you can understand these charts, are also very useful for your project here in DSS, but also potentially for your business, understanding the impact of age on churn, distribution of such information. So quite useful. You can build as many as you want, as well as correlation matrices, PCAs, and so on. So quite cool. And then the third time you will be able to explore your data will be by creating custom charts. So you'll be able to create histograms, pie charts, and so on, but also map visualization and so on. So very quickly and easily create some charts. I've got some examples here, as well as dashboards and so on. So very easy to create and publish for your internal use, but as well maybe publish some insights for the business and so on. And so, as we said, we're ready now to train the model. So we already did that previously, and so I encourage you to have a look at that in more details. But basically, DSS has a machine learning environment that is visual. All of that you can code as well, but you can also use here the visual machine learning workbench, which is running on the top of, in this case, scikit-learn. Where you're going to have full control over, how to split your training data, how to maybe do 70-30, 5-focus validations, and so on, metrics that you want to optimize the model for, ability to create your own custom metrics as well. You'll have the ability to get, sort of like warnings on your projects. So for overfittings, for data leakage, making sure that your data is actually, let's say, of good quality to train your model and so on. Here, everything for feature handling, feature selection. So a lot of things for the data scientist to use, but also for the non-data scientist, knowing that all of this can be pre-selected and automatically, let's say, choosing the parameters for all of that, so that also the citizen data scientist can work in efficient and safe manner, basically. And so here we will select the algorithms. These have been shortlisted for the type of prediction that we have, which is here a classification. So if we had a regression, we would have different parameters and different algorithms here altogether. Ability to indicate how many what parameters you want to grid search, if you want discrete values or if you want brackets of values, and so on. The ability to distribute the parameter search on Kubernetes, for example, here, as well as to change the parameter search method and so on. So a few cool things. And so here you can see we already tried a few times with different algorithms, different parameters. And so every time you will be able to try and iterate, and as you move towards your session 10, 15, I don't know, you will be able to get to your best model. So here we can see, for example, in my session 2, I had the highest AUC score, and this might be the model I want to deploy. Maybe I want to analyze a bit better what's been happening here. So visualize your model as a decision tree. Variables importance as well, quite useful for you as a model builder or also for the business. And then everything around ROC curve, confusion matrices, all of this is there, automatically generated. Again, things you can probably code maybe, but also things you can save time for prototyping and so on. And so once you've chosen a model that is relevant for you, you might decide that you want to use it in the flow. And so for this, we're going to call it deploy, but it's not deploy in production yet. It's just to say that we're going to use it to score our new data. So we had our new customers on which we want to predict who will churn or not. Here we don't have the churn information, of course, because this is what we wanted to predict. And here, this is what we're actually going to get, which is our new customers and the prediction on whether they are at risk of churning or not. Then you can use that with marketing tools and so on to target them, to try for them not to leave your service. And so all of this will be done now and ready for deployment. Before I do that, I want to define basically data quality metrics and assign them some checks. So for example, here, I always want to make sure I have certain columns in my data set. I also want to check maybe that my customer group is not going to be below a certain level or above a certain level. Maybe you want to keep track of standard deviation of another level of variable and so on. And then once you have actually activated these metrics, you can assign them some checks. So for example, I always want to make sure that I have here 6 columns. And if that's not actually the case, to stop the automated process and to send me a notification. This is also something I'm going to be able to do for my machine learning performance to avoid model drift. Sorry, to get there. And so to say, for example, I always want to have a AUC above a certain level. And if that AUC is not, for example, above 0.8, to say that I want to retrain my model, maybe first I will want to say something like rebuild my training data set here. Maybe a second step should be to retrain my model in the pipeline. And so very quickly, you can create scenarios here for automation, for model retraining to avoid model drift, but also simple things like verify the data quality of your project and things like this. And after, let's say 3, 5, maybe 10 scenarios, you will have a model that will be fully responding as you expect in production. You'll be able also, of course, to get some alerts. Triggers can be time-based, based on dataset change and so on. The reporters can be sent by email, via Slack, via Teams, and so on. So really the ability here to have a pipeline that once in production will be running as you expect and without you needing to keep an eye on it constantly. Now, that being said, of course, you want to be able to monitor your scenarios and your pipelines. And so all of this you'll be able to do at the project level, but also, of course, also at the instance level, looking at scenario execution, whether it's been running correctly or not, and so on. So while this loads, we can actually go ahead and deploy into production. And so for this, we're going to come here to bundles. So bundles are actually the artifact that you create when you deploy to production with DSS. And so this is going to be also what we use for versioning. So this is going to be this V1, the snapshot of my project as we know it now. So this is what we're going to start deploying right now. And all I have to do is to basically to publish it on my deployer node, which is then going to allow me to push it into production. So what we discussed earlier, basically to my automation node. So what we just did was to push this artifact to the automation node, where it's going to be basically running in production, either in sandbox or in design or in test phase or pre-production. And if after maybe 3 months, 6 months or whatnot, you have a better model, new project, new changes to your project, you're going to create a new bundle, and all you have to do is to call it maybe V2, document it as you want to, and then publish to the deployer, and it will be appearing into the automation node as well later on. And the deployer will allow you to manage your batch models as well as your real-time models all in a central place. So this is it for, let's say, collaborating, documenting, versioning, and deploying with DSS. I hope this was useful, and yeah, I'm looking forward to your questions in the Q&A section. Thank you so much. Bye.